This is the first vodcast for Unit 4 of Earth Science and Geology, and what we're going to be looking at in this unit is plate tectonics and the evidence supporting it and how they came up with this theory. But before we get into that, we really need to understand how to read and interpret maps. Because a lot of things that we do to actually measure how fast continents are drifting is based on maps, and so we need to be able to work with those before we actually discuss that. So that's what we're going to be doing in this vodcast. We're going to be going through, in this vodcast particularly, looking at the map scale and how to use that to figure out an actual distance. So these kind of maps, you can see have a bunch of squiggly lines on it. These are specifically known as topographic maps, or topos for short. And we're going to get into what all these weird squiggly lines are, but this is a map, all right, known as the Mitchell quadrangle map. You're going to be using these a lot in this class, and it's actually part, or measuring, or looking at southern Indiana. If you've ever been to Spring Mill State Park in southern Indiana near Orleans or Mitchell, you've been to a place somewhere on this map. But what we're going to be doing here again is two things: determining the scale and using that to determine distances. So you have to look around on these maps to find the scales. They're in different places. Sometimes they're at the bottom. So if I move this up, I'll show you at the bottom here. We have two types of scales. We've got a ratio scale of 1 to 24,000. We also have a graphical bar, or representation of that scale, which we will look at both of these and how to use them on this map. First off, we're going to be using that ratio scale. Now, that ratio scale is just describing how much the map has taken the real world and shrunken it down. In this case, it was a 1 to 24,000 ratio map. So that means in real life, everything on this map would be 24,000 times longer or bigger than it actually is shown on this map. So if I measured an inch on this map, it'd really be 24,000 inches. If I measured 1 foot on this map, it'd be 24,000 feet. If I measured 1 centimeter on this map, it'd be 24,000 centimeters. Really important thing to take from this is that the scale does not indicate any certain units. Whatever units you start off with, inches, feet, centimeters, whatever you use, that would be what it spits out. Okay, so step one is, if we want to determine the distance on any map, is to figure out that scale. All right, so we're going to use the ratio scale. And we know the ratio scale of this map is 1 to 24,000. All right, that's the scale. Next thing we need to do is actually take a measurement, all right, of something that we want to measure. So we need a tape measure. Okay. Now, you're going to be using these tape measures. Usually one side's inches. We do not want to use inches. We want to use the centimeters side. All right, we're going to be using a lot of metric. So let's say I want to measure the diameter, the distance across Spring Mill State Park here. To do that, I'm going to take my tape measure and I'm just going to measure straight across. Now, a couple things with using these tape measures. Notice that it has this little piece on the end. This is not really that accurate. Okay, so since it's not that accurate, we want to kind of ignore that it is even there and go to the first spot that I know is a true measurement. In this case, looks like it covers up everything up to the 1, so let's just start measuring everything from the 2. Again, this is to be as accurate as we possibly can. Accuracy is important. So if I want to measure the length, or the width, of Spring Mill State Park, okay, so here's the western boundary. I put it right on the 2. And then if I go across here, it looks like we have 13.1 centimeters. All right, 13.1. Now, it's really not 13.1 across because I'm starting from the 2. So that means it's really, if I take away 2, 11.1 centimeters. So on this map, all right, it is 11.1 centimeters across. This is my measured distance. That's the second step. You're going to actually take a measure of the map distance. So how do I then take this and convert it into a real measurement? All right. Again, this scale, 1 to 24,000, is describing that every unit that I measure, it's really 24,000 times that. So all I need to do to get this into a real world measurement is multiply the two together. All right. So you should have your calculators handy. So I've got 24,000 times 11.1. That gets me 266,400 centimeters. All right, that is what that distance really is in real life. But I got a problem. This is the wrong unit to use. I would not measure this great a distance in centimeters, just like I wouldn't measure your height in miles, and I wouldn't measure it in millimeters. I'd use feet or even meters. I would not use centimeters. So the last step that we have to do here is actually take this, convert it into kilometers or some other usable unit. And we're usually going to keep that into kilometers. Right. So the final step here, if I'm going to use the ratio method, all right, again, this is the ratio method, is take this and convert it into kilometers. Now, to do that, I need to know how many centimeters are in 1 kilometer. Well, there's 100 centimeters in a meter. That's why it's a centa, like a century. And a kilo means 1,000. There's 1,000 meters in 1 kilometer. So there's 100 of these in 1 meter and 1,000 of those in 1 kilometer. That means all I need to do is divide this by 100,000 centimeters per kilometer. All right, that's how we take centimeters and convert it into kilometers. All right. So you could either punch that into your calculator, or you could just take the decimal and move it over those 5 spaces. 1, 2, 3, 4, 5. That means 2.664 kilometers. All right. So basically 2.7 kilometers wide. Now, I said that's one way you could do it. You can also use a different kind of scale. All right. Depending on your map, all right, if we have a map like this, or if I try to use a different map, say this map of Mammoth Cave, I look down at the key, I can see I do have that ratio scale, 1 to 28,000 here, but I also have this bar, all right, this graphical bar. This graphical bar is actually showing you how long, say, 1 mile or 1 kilometer is on the map. Right, so I can measure that and convert it straight into kilometers without a 2-step process. So if I look at this map and measure from on this graphical bar, there's several of them. There's kilometers, there's miles, and there's feet. All right, we pretty much always want to stick with the kilometers. If I measure that from the 0, not from the edge, but from the 0, and again, knowing that I start from the 2 centimeter mark out to that 1, it looks like that's a distance of 4.1 centimeters. All right, because again, I'm starting on the 2, going to 6.1, subtract off that 2, 4.1 centimeters. So if I'm using that graphical bar, right, to represent the scale, I just learned that 4.1 centimeters on this topographic map, and that is specific to each scale. Again, this is a 1 to 24,000 ratio scale. That means 4.1 centimeters is actually equal to 1 kilometer. So I could use this to determine the distance that I already measured. I already measured that the width is 11.1 centimeters. And if I divide that by this graphical bar representation, 4.1 centimeters per kilometer. .7 kilometers. So pretty much the exact same thing I got over here, but much quicker and easier. Again, this 4.1 is only good for any map with 1 to 24,000 scale. If it doesn't have a 1 to 24,000 scale, such as if I go back to this map, which, zoom in a little bit. On this scale, so 1 to 28,000, all right? And if it was the exact same, we would see that from here to here would be the 4.1. And if I put this up here, measuring from the 2, we can see it doesn't get to the 6.1 that it did before, only 5.5. So this is a completely different ratio, completely different graphical bar representation, and we would have to determine, based on this map, a different bar scale. Okay, so that's pretty much all we need to do. You need to know how to find the scale, what the scale means. You need to be able to use that and to determine the distance measured on a map. That's what your first assignment will be.